Okay, we are set to go. I would like to thank everybody to be here, and I would like to thank Nexenta for giving us the opportunity to be here, and our partner Layer 8. So, I'm going to talk a little about Ballou and our journey with Nexenta. We have grown quite large in the storage. Present time we have 304 terabytes. So, talk about a little about that. Ballou, as a company, was founded by Robert Ballou in the US in '97, and was brought to Sweden later on, and some different owner constellations, and it ended up in Adaptio ownership. So we now belong to a group in Malmö, and we're focusing on server operation, web hosting, and other services. So that's our main focus, and our focus for the future is cloud computing, virtualization, and storage, basically, continuing our web services and mail services. And we are very well known for our support in the industry. And a little bit about me. My name is Daniel Jacobsen. I work as a storage and virtualization specialist at Ballou, and I work with IT in soon 10 years. So if you want to see all the stuff I've done and work with, please check my LinkedIn in the end of the session. Was at the Open Storage Summit 2010 San Francisco, met Bill Moore, so good stuff. Nexenta certified engineer from 2010 and now architect from yesterday. At home I have my white box, which basically is a VMware ESXi installation. I will tell you a little bit about that in order for you to get a hint who I am as a person. And you can see my beautiful son here also. So, my white box was inspired by the vTardis project. It's basically a VM guru who runs nested ESXi services and build his own private cloud services for testing. And I basically done the same. So I use a Viga SR2 motherboard for that. It's a 2-socket system, so I run Xeon processors on that, which also is overclocked to 4 gigahertz sealed water cooling. I run 32 gigs of RAM, and damn you VMware for the memory cap for that. I can run 48 gigs on 4.1. Just to have something to play with together with Nexenta, I bought 2 RAID controllers, which has direct path to 2 Nexenta machines, which is in a cluster, which one of them has a direct path to the internal 6 gigabit SATA controllers for SSD. So, and I present that to my host as a data store, and I can dedupe my virtual machines and take full advantage of Nexenta virtualized, basically. I use it mainly for lab, basically. I have Windows 7 VMs, which I have direct path my graphic cards to. I have 2 at the moment. I actually tried running 4 virtual machines with 4 graphic cards, work perfectly. So 4 person can play at my machine at one time. How it all started? Well, in 2010 I began my journey at Ballou, and when I came to Ballou, no one was actively working on storage, and Ballou was dying for more storage in order to meet future needs. Our needs at Ballou for virtualization mainly, and requests from customers, basically. So we have an internal review about that, and we reached out to peers, we reached out to technology partners, and we did our own research. I myself have seen Nexenta grow since first release, worked with Solaris before, so I've followed since first beginning. Took some proceeding, I can say, against well-established vendors. But so why did we end up with the Nexenta after all? First, CFS, all the great features MZFS gives, which is agility, scalability, cost, no vendor lock-in. You have to be able to quickly change and adapt in our industry, and you cannot really offer the prices with a NetApp system. Future safe, basically, because it scales with the hardware also. And Nexenta system as a company is skyrocketing in growth, and they are really out there showing new cool features, primarily for the stuff that we are interested in, like cloud computing. We have the recent Allowance plugin, the cloud backup plugin, that you can transfer your data to Amazon or Google or OpenStack objectives. And of course, great support from both partners and Nexenta itself. So, our first order, in time being, it was a company called Trust IT, as we chose as partner, and the hardware they were offering us was too expensive, my CEO thought. So we actually went to a local hardware vendor, bought Supermicro hardware, and still had Trust IT as partner for the Nexenta support. In the middle of this, Nexenta changed their requirements for the HA cluster, which was it required gold license, and a gold license require only certified hardware, so we have to double check all the hardware we bought, but it was no problem. It took a little longer to get the placement. So, what kind of hardware did we buy? We bought a 2-node cluster with 2 CPUs, 25 cores, only 25 gigs of RAM actually, but it's upgraded now to 120. Quad NICs, 2 HBA for SAS, nothing particular, and a replication node with basically the same setup as the head nodes, exceptions from the quad NICs and a single CPU, because it's going to only handle replication. The purpose for this is VPS storage at time being. It's now running our not yet released public cloud services. We have a few customers testing it out. And you can see all the specifications here. And we have a very large customer who needed plenty of data. So we bought 2 of these large G boards and filled them up with drivers. The daisy chained, so you can see 80 terabyte usable in the cluster, 64 terabytes usable on the replication node. So, installing the first cluster, actually Andy Bennett himself did an on-site verification of our cluster. I think he spent most of his time charging his phone actually, but we had a good moment and it all went very nice. The setup and testing nowadays are done by partners, and the verification is done by Nexenta remotely. So we need to get all that data from the customer, right? So we send the replication node and the JBoard directly to the customers, service provider. The setup was 4 RAID C2, 11 devices plus 1 hotspot. 64 terabyte usables, as I mentioned before. It was sent to one of the largest telcos in Sweden. Their data center was about 5 or 6 foot fields. It's enormous. And the customer have a Windows machine that I log into in order to get all the stuff up and running. So when I came there, they have unpacked the replication node and the JBOD and have it all set up. So I logged into Nexenta, creating the VDEFs and the pool, and I connected to the network and have it up and running. So on their Windows machine, they have fiber channel out to 5 different EMC systems of a large fabric, and you can imagine 5 or 6 foot field and 5 or 6 foot planes. It's huge fabric. So it was quite funny to see A to Z LAN mapping in there. They have a huge problem with backups because the backup took 2 weeks to complete, and they have corrupt and missing data all the time. So we're not happy about it. So when shit hit the fan, when the data was transferred to our replication node, the telco dropped both the replication node and the JBOD from a table straight down the floor. A few drivers, most of them flew out the JBOD and was mixed on delivery. We actually got the damage a week after, and try restoring that on a different storage system. You just plug in with CFS, it finds the pool anyway, but it's been damaged. The hardware's been damaged. The replication node was dead on arrival, so we order a new replication setup and transferring the data to JBOD. So we connected the JBOD from the damaged equipment to the cluster, but which caused hardware problem for us in the cluster, which we isolated to actually the HPA card, which we connected JBOD, but it required months of troubleshooting to get that result. Meanwhile, between that we have cluster instability due to mainly in older version of Nexenta cluster, your heartbeat on a single device, which is called a quorum here. Nowadays your heartbeat on 2 or more devices in the pool. So we decided to disconnect it from cluster in order to have it working. And when the replication setup arrived, we instead connected the damaged JBOD to the new replication node and then transferred it over to the cluster's JBOD. So the delivery was late, but all the data was intact thanks to CFS, basically. We saved their asses. The replication service itself. We use NexentaStor AutoSync, which is CFS send and receive. So we snapshot once an hour, 30 days, 3 months. The cluster node is pushing the data to the replication node and not the other way around. We use 7 different data sets for that, transferring each separately. The growth when we are snapshotting and the customer's growth rate is about 3 terabytes a month. So you can imagine. Oh, sorry, wrong one. I had to find out how much data, how much files they actually have. So I ran a dry run rsync. They have 7 million files in the first transfer.
17 million?
Yeah, 17 million files. A file is almost 1 gigabyte large. So it's quite huge. As most companies this day, we have a VMware environment. And when I came to Ballou in 2010, we were constantly extending our VMware environment. So we have excessive VM growth and performance issue because of it. And we have, as a hosting company, hosting web services and mail services and databases, we are seeing a lot of random IOs, small IOs. So it was just killing the SAN. So the solution, as we run today, we added 2 new expansions. We replaced 75% of all hard drives. We changed the RAID type from RAID 5 to RAID 10. Very expensive doing that, but no real choice actually. We had to do it. And we will not invest in more hardware for the IBM SAN. Instead, I will talk about the solution we will migrate to later on in the presentation. So we need more storage. Our backup software for VMware had a release of a new major version, which basically it needed a new place to put the storage on. So our old open file also grew out of space because we have excessive VM growth. So we bought a few drivers, inject them in. Not much to say actually. We set it up with RAID C2 at first, but changed it to Miro due to the IO load. And we don't run any seal on that actually. Nothing special. And we have a customer who needed performance for databases. So we bought a few drivers for them and Intel SSDs. So they have 4 Miro sets with 15Ks for databases, which is exported with iSCSI to the customer. And we tuned each CVOL matching block sizes per database in order to maximize the performance and other stuff like that. And we can really fine-tune anything basically. Yeah. And guess what? We need more storage. Almost a year after the first HA cluster installation, we added 2 new 45 JBODs, bought 11 new devices per JBOD, usable around 16 terabytes in both the HA cluster and the replication node. So for future needs, we just add a new VDEV with 11 devices in each, and we can expand within that JBOD without touching anything basically. Also, we're buying a little bit more licenses than we need in order to be able to add a few devices, make changes to pool types, stuff like that. So. And we are building a new HA cluster for VMware vCloud Directory, which is ongoing and eval testing. And for that, we seeked out a new partner, Layer 8 here. And we are basically sharding up the systems. With that meaning, is you have one HA cluster, smaller HA cluster, which don't run as many virtual machines as you can do. Instead, you're limiting a HA cluster to basically a few blade centers, and then you have a new HA cluster and a few blade centers instead of running like 20 blade centers on one HA cluster. Because we thought it was too risky to have a single, basically. And it's built from ground up for scalability, redundancy, performance. And in this environment, we will move our existing VMs. I don't know what we're gonna do with the IBMs, basically. I know. So, layer 8, a little words about them. Initial contact, October, November 2011. We met us in our office site. Proposed a new HA cluster for VMware. And it was challenging, yet satisfying working with them. We have a lot of stuff going on. So why Layer 8 as a partner? They have a focused on Nexenta, which brings us very close to them because we have a lot of Nexenta going on. They're certified and they have a dynamic storage platform, which I'm going to talk about later here. Offers key hardware solutions for NexentaStor, so it was a great match. This is basically what their solution is about. It's 2-node system, 288 gigs of RAM, 2 CPUs, etc., etc., etc. And we have 2 Jade boards underneath in order to scale it properly both with the STEC SUSE RAM and SUSE IOPS. We are really looking to moving into this storage with our VMware environment, so should be quite fun. So here's the thoughts about the pool design actually. We have 2 nodes, both have 1 pool each, so we will be running this actively. On the first node, so speaking, we will actually run dedupe on the operating system. So we will have data sets or CVOLs dedicated for Windows or for Linux or for Solaris, and not one big pool of all operating system or data set, I mean. So we are seeing a large dedupe factor there. And the other pool is for the more unique customer data. So that's why we have both the SUSE RAM and the SUSE IOPS drivers there. And the net usable storage is 12 terabyte. This is basically how we're going to scale it out. As we need more blade centers, we will simply add them. But until the Nexenta can handle it, so speaking, because we're going to shard it up, pod it up, so speaking, and we will just add a 3rd node if we need to. So running a 3rd node in a +n factor, or have it dedicated to a 3rd pool, I don't know, it's too early to say. Yeah. So our future with Layer 8, they're going to review our first cluster installation and replication, because a lot of things have happened in 2 years, and we need that up and tip-top, so speaking, and standardize the storage to the present, to the new standard, basically. And we might actually look at the Metro cluster in the future. So this is how it looks, all in place. We have our off-site replication there. We have our first cluster on the right side, and the dynamic storage platform from Layer 8. on the left side. We use NexentaStor Community Edition for testing and eval, which we actually maxed out the 18 terabyte limit. An old IBM server connected with SCSI enclosures. So we're reusing our old hardware for testing. And that's about it. Here's a few contacting information for Ballou. And here's for me. If you want to check in my LinkedIn, it's there. So it's Q&A now. Anyone have any questions about something? Just go ahead. Yeah.
If you look at the slide that you presented with the setup of the active with the tools, one back. This one, yeah.
Yeah.
Don't you use any layer 2 caching, layer 2R on the first pool? Yeah.
No, nothing here, because we are expecting the dedupe to be very nice from the RAM from the node itself, actually. So when we hit that boundary, we will probably add SUSE IOS or SUSE RAM.
What if you would boot up all those VMs? It will give a boot storm. So
yeah,
Do you mind if I kick in?
Yeah, sure.
So the intention is, as we have the active, so one of the head nodes will care for one pool and the other pool. That means that we have one head node has 288 gigs of RAM for first level cache. Yeah. So you do have a cache of 200 plus gigabytes. And when they expand, there might be a need for additional caching for our SSDs. But for now, we think this will be enough, because there will be the dedupe, and there is relatively small amount of data, because it's so heavily deduped.
Yeah.
So that is the intention behind it. Okay. And therefore we focus to put SUSE IOS and SUSE RAM on the other pool, which is more random.
And the VMs with the swap file, that's also used located on the second pool. Because if
yeah.
That is the intention, yes.
We will place that on the second pool. That's correct. So you will basically boot it out of RAM on this one. Yeah. That's the photo. Anyone else? Any questions? Nothing? All clear? Well?
Don't drop the laptop.
No. Well, I would like to thank everybody once again for coming here, and it's been fun. Thank you.